All right, welcome back. This is CS50. This is the end of week 7, and it's the end of that scavenger hunt from problem set 4 that you might recall. After recovering all of those JPEGs of staff, you were challenged, if you'd like, to photograph yourself with as many of those folks as you can. We got a whole bunch of submissions over the past few weeks, indeed quite a few right before noon today, just some of which are those here, caught here in, looks like Annenberg Hall at office hours, one here in Lowell House with Nick. Here's Ramon being caught on the phone. This was at a CS50 lunch. This was Jason Skyping with a more creative classmate who phoned him this way. We don't know what this was, but that's worth a gigabyte. Here was Chang, who literally ran off the stage to avoid being photographed one day, but was eventually caught. Here's Nick. Here's Nick. Here's Nick. And here is Allison down by the fields, and Zamila even was found at a ballroom competition. So we will go through these photos, figure out who submitted the most, the earliest, and reward one fabulous prize as promised in the spec. And we'll also follow up about the space that was involved. A couple of announcements. So lunch is again this Friday at 1:15 p.m. if you'd like to join us, RSVP at that URL here. Jason appears again here from one of his sections a couple of years back, which happened to fall on Halloween, and indeed he dressed as a pumpkin that particular year. If you watch this section of his from 2011, section 8, if you are curious, at cs50.tv, I think this was the year in which his air pump was working. If you then watch the similar section in 2012, you'll see Jason much deflated since the suit no longer functioned, which is only to say, this Friday, if you'd like to carve a pumpkin with Davin and Gabe and others, RSVP to the heads at cs50.harvard.edu address. It promises to be great fun. Davin, we're told, has carved pumpkins all of his life. Gabriel from Brazil has never carved a pumpkin for Halloween, so be there with them as he learns. Seminars, meanwhile. So you'll learn soon about what our expectations are for the final project, which essentially will boil down to designing and implementing most any project of interest to you, albeit subject to the approval and guidance from your teaching fellow. Toward the end of the semester, we introduce a number of seminars, which are optional classes led by the teaching fellows and Harvard staff, friends of the course across campus, on various topics that are tangential to the course's underlying syllabus, but nonetheless applicable, fun, and different for potential final projects. For instance, first, if you'd like to register, head to that URL there. And this is the lineup for this year's seminars alone, but realize we have dozens of seminars from years past, all of which are linked in the seminars menu option of the course's website. So if you're thinking about going beyond your comfort zone or picking up some new skills, for instance, programming iPhone apps with Swift, a new language from Apple, or Objective-C, or Android apps, or programming Hue light bulbs, or any of the topics up here and more, do check out the registration page. So we began and concluded on Monday with looking at HTTP. So quick refresher, HTTP, Hypertext Transfer Protocol. But what does that really mean? Hello. What does that really mean? Is that a hand, or? I know you're just scratching your head, but you want to propose what HTTP is? I missed the last part. How computers communicate with? Good, with internet servers, and specifically web servers, because recall there's a bunch of services on the internet, some of which you use probably daily between chat and web and email and the like. And HTTP is just the protocol that web browsers speak when communicating with web servers, and vice versa. And the analog in the human world might be I extend my hand to shake some other human's hand, and he or she acknowledges by extending his or her hand as well. So that's just a protocol, a set of conventions. And what indeed are those conventions? Well, it just boils down to sending messages back and forth, as we depicted here. And there's a couple of ways in which you can send these messages, and perhaps the most common is known as GET. And we'll see a contrast to this before long. But a GET request from a browser to server just looks like this. It's a bunch of text that it puts inside of a virtual envelope. On the outside of that envelope go a couple pieces of details. What needs to go on the envelope, so to speak, in order to get a request like this from me to a web server? Yeah. My IP address in the from field, so to speak, and of course, the recipient's IP address. But in the case of a web packet, we need a little more detail. It's not sufficient just to send an envelope to a server, because that server might be listening for different types of internet traffic. So what else do we need besides the recipient's IP? Yeah? Good. TCP Address or port, as it's called. Close, but a TCP port number. And there's a bunch of these, but surely the most familiar should eventually be 80, which is the default one used for web traffic. And another familiar one soon will be 443, which is used for secure web traffic, URLs that start with HTTPS. So this is what goes inside of that envelope. And get slash just means give me the default web page. Give me the root of the hard drive on that web server. And hopefully the web server will respond with OK. And the number 200, which is just a convention saying, yes, all is indeed OK. Here's the web page. The type of the web page is going to be text, but more specifically HTML, which we're about to dive back into. And the ... just means here is the HTML. And that's where we pick up the story today, actually writing HTML, hypertext markup language, which is the language in which web pages are written. It's not a programming language. There's no functions or loops or conditions. It's a markup language, as we'll again see today, that allows you to specify how to structure and stylize aesthetically a web page. So this was the one and only page we really looked at, if briefly, on Monday. And notice a few salient characteristics. There's a lot of opened angled brackets and closed angled brackets. And in between those angled brackets are words. And we're going to start calling those words tags. So open bracket head and close bracket head are the open and close tags, or the start and end tags, respectively, of an HTML element, as we'll call it, called head. And the same jargon applies to body and HTML and so forth. And what's nice about HTML, and indeed we'll spend terribly little time on it because you'll mostly just figure out what features it has when you actually have a concrete problem to solve, you'll find that a browser is pretty dumb. It's just going to do, not unlike a computer, what you tell it to do. And so when you have open bracket HTML at the very top there, that essentially just means, hey, browser, here comes a web page written in HTML. When it sees open bracket head, that just means, hey, browser, here comes the head, or the topmost portion of my web page. When it sees a close bracket head, that just means, hey, that's it for the head, stand by for something else. And that something else is apparently going to be the body. And when you don't have a tag, like you have just hello, comma, world, that's just going to be raw text that ultimately is displayed in the screen. Now, you'll notice, too, the indentation here. You can probably infer how we're stylizing it. Every time I open a tag, so to speak, I indent. And every time I close a tag, I unindent. Similar in spirit to curly braces. And beyond that, I'm kind of using my judgment. Notice that I didn't bother hitting enter inside of that title tag. Why? Well, I just decided it looked a little cleaner to me, the human, to just not bother doing that. So again, there's some judgment calls, just like there is in C or any language. But notice, too, that this indentation lends itself to a mental model, if not to overcomplicate it, but a tree. Right? If you think of a web page, apparently written like this, as being nicely indented that way, you can almost think of the open bracket HTML close bracket tag as demarcating the root of a node, a family tree style node in the style of the trees we looked at last Friday. And indeed, we have on the right here what we'll call a DOM, D-O-M, document object model, fancy way of saying a tree that represents that HTML. And notice that HTML has, we'll say, like a family tree, two children. On the left is head, on the right is body. And just as a mindless thought exercise, head, of course, has how many children, according to this structure? So just one, title, and that's why we have the arrow going from head to title. So it's as though that person in the family tree had just one offspring. And then title itself can be said to have a child too. Recall that the HTML had hello, comma, world beneath it. And I've simply drawn it with an oval instead of a rectangle, just to convey semantically that even though it's a node in the tree, so to speak, it's sort of fundamentally different. It's not a tag, or more properly, it's not an element. It's just a text node, if you will. But these are completely arbitrary human conventions. This is just now my way of representing what I'll, as an aggregate, call the document. And as an aside, the thing at the super top left-hand corner, open bracket, exclamation point, doc type HTML, this looks like a tag, but it's this stupid corner case where that is just there, copied and pasted, to indicate to browsers this is HTML version 5. The world keeps changing what the first line of code in a page should be. This just means version 5. So it doesn't quite look like the others. All right, so with that said, you'll now appreciate this fairly stupid tattoo someone got. All right, and now let's actually dive into doing something with this. You'll recall that last time I opened up the CS50 appliance, and I did something as simple as opening up gedit and I save the file, even on my desktop, nowhere special, as hello.html. So let me do that again. Hello.html, enter. And now in this file, I'm going to go ahead and replicate what we just saw. Doc type HTML. Then I'm going to do open bracket HTML, close bracket. And then I'm going to preemptively open and close the tag. Why? Just so I don't forget later. Just good practice, like opening and closing curly braces all at once. And then what came next? Think of the tattoo, the head. And then in here, I had the title, I think. And the title was arbitrarily hello world, close title. And then down here, the body, of course. Let me close the body tag. And then just somewhat redundantly, I had the same thing down here. So I claim that this is a web page. This is something that could now live on the web, even though, of course, it's literally living on my desktop right now. But indeed, if I minimize gedit, I'll see on my desktop its icon. Even though this is the appliance, you could do this on Mac OS with text edit or Windows with Notepad even. And if I go ahead and double-click that even and select, well, let's not select that because Chrome's not opening. Let's go ahead and open Chrome. And then do Command O for open, and navigate to my desktop and open that file. That is how a browser interprets HTML. Top to bottom, left to right. Hey, browser, here's HTML. Here's the head. Here's the title. Here's the body. And indeed, this is how it renders that web page. But notice the URL. None of you could pull up this specific page on your laptops right now, even inside of your appliance, via that URL, because file : / indicates it's actually on my file system, my hard drive, not yours. So this isn't all that useful. Let's now move toward using an actual web server. And it turns out the CS50 appliance is more than just an environment where you can write C code and compile it and run it like you've been doing. It also has been configured by the staff to represent a typical web server that's on the internet, one that you might pay for or one that's in the so-called cloud. And it's running standard, free, open source software, for instance, something called Apache, which is perhaps still the most popular web server software in the world that thousands of websites use today. And it also even has software like MySQL, which is a database server that we'll eventually get to, which is only to say I can start treating my appliance as a full-fledged server that I'm not paying for elsewhere. It just lives on my own laptop for development and convenience purposes. So let's go ahead and take advantage of this. I'm going to go ahead and open up a terminal window. And I'm going to go ahead and move. Actually, first I'm going to navigate to my desktop. If I do ls, there's hello.html. And I'm going to go ahead and start using a new directory we've not used before today. Hello.html, I'm going to move to /vhosts for virtual hosts. More on that in the future. And then into a directory called localhost, which is the nickname given to almost any computer, whether it's Mac, PC, or Linux computer. And then specifically into a directory that we, the staff, already created for you when you downloaded the appliance, called public. And as its name suggests, anything I put in this folder, in theory, is going to now be public, at least to people who have a direct connection to my computer. So now let me go ahead and do cd to that same directory so I can see what's going on, and type ls, and indeed that's the only thing in there. I claim now that because I have put this file in hello.html inside of a directory called public, inside of a directory called localhost, inside of a directory called vhosts, which, thanks to CS50 staff, has been pre-configured to be the root of your web server, I can now hopefully do this. I'm going to open up a new tab, and I'm going to go not to file : / I'm going to use actual http/localhost, which again is the nickname for my own server. And then I'm going to go to what file name, just to be clear. Where is this story probably going? Hello.html. So in other words, I want to now visit my own computer, my own appliance, as though it's an actual server. Its nickname is localhost. But think of localhost as like facebook.com, google.com, whatever. It's just my local name. And then the file I want is in the root of the hard drive, so to speak, or the root of the web server, ergo the /, and then the file name, hello.html. Let me zoom out and hit enter. And indeed, there's now my web page. So it's slightly different, and it's just as underwhelming. This is the old version. Let me shrink the font back. This is the old. This is the new. But what's fundamentally happening now is that HTTP is being used. Let's make this a little more clear, or if you will, a little more complicated. Let me go to the bottom right-hand corner of my appliance and notice that all this time there's been a number that is the unique address of your CS50 appliance. It's a private address, as implied by the 172.16, which just means only you physically can access this web server. Everything is firewalled and nicely protected from the rest of the world because of this addressing. And now notice, though, if I go to this address, not in my appliance, but in Mac OS, I'm going to go back over here. This is my Mac now. And now I'm going to open up this version of Chrome here, and I'm going to go to http://172.16.254- and I forget the rest, 133. So I'm going to visit from my Mac that IP address /hello.html, enter, and now I see from my Mac that my CS50 appliance, whose IP address is that number, is indeed behaving like a web server on the internet. It doesn't have a nice, easy-to-remember name like facebook.com, but it's using HTTP apparently, even though Chrome is kind of simplifying the world for us by not showing us HTTP. But this is indeed exactly that. Chrome is just saving some keystrokes these days. And that's what we now see. So that's all fine and good, but it's a pretty underwhelming web page. Let me go in and do something a little different now. So let me go back to gedit. And instead of hello world, let's put an image. And I claim from before, let me go into my local host directory public. And let me go ahead and copy a whole bunch of files from today from my Dropbox folder into here. Now, if I type ls, look at all of these files that I've distributed via the course's website in advance of today, one of which is still hello.html, so there's that one. And recall this silly one from last time, cat.jpg. So let me try to embed cat.jpg inside of my web page. I'm going to go ahead and do cat.jpg, save. Let me go back to Chrome, and let me zoom in the font, and now reload. Oops, where did I put this? Stand by. I still have the old version from my desktop open, so let me go into my vhosts, my local host, my public, and hello.html. So now let me go ahead and say cat.jpg inside of the body where I want it to be displayed and reload. Of course, this is not correct. So I need to tell the browser a little more deliberately what I want it to do. Simply typing the name is obviously not sufficient, so recall that there was another tag, image. IMG for short. That's just because humans don't like to type full words. And then we can do source equals quote unquote cat.jpg. And now I'm going to do one thing different here. Even though all of our tags thus far have had this notion of a start tag and an end tag, that doesn't really make sense for an image, right? An image is either there or not there. And so the humans have come up with a simpler convention. When you have a tag that can both start and end at the same time, it can be empty, so to speak, just put the / inside of the tag at the very end. Now let me go back to my browser, hit reload. Damn, something's wrong. And you've probably seen this occasionally on the web, even if it's not been your fault. It's the web server's fault. What does this seem to indicate? It's broken. That's where the image belongs. Yeah. It doesn't have access to the image. That, or even worse, maybe it doesn't even exist. Let's see if we can't diagnose that. Recall from last time that if in Chrome, in the appliance, or even on your Mac or PC, you go to the Developer menu and go to the Developer Tools option, which probably you've not used much or ever. And if I go to Network and reload the page, let's actually look at the HTTP requests that are being made. It looks like hello.html is indeed OK, hence the 200. But cat.jpg is a 403. So it's not 404. File probably exists. 403 means forbidden. So this is a little confusing. I'm going to go back to my terminal window. Let me zoom in up here, and let me do an ls. There's those same files. Now let me do ls-l, which you've probably used before to look at file sizes, maybe, or timestamps. And we see a whole bunch of overwhelming information, but notice a few details. Here's hello.html in this row here, and here's cat.jpg. And it's just the appliance being user-friendly by highlighting JPEGs in purple like this. But what else is different besides the file size and the file name? Yeah, there's two more R's over here. Notice what hello.html has going on. So it turns out that the name of this directory, public, is important. Anything in this directory is meant to be public. But it's not sufficient just to drop files in there. You also need to change the mode of the files, change the permissions of the file to proactively not be the default setting, which is that only I can read and write it, I being the owner. I want the whole world, everybody, to be able to read my file, so to speak. Read just means view it. And indeed, as you'll see in problem set 7, that's what these R's mean. These two R's mean let everyone else in the world also read it, especially now that it's in this directory. So the simplest way to fix this is to go to my prompt and do chmod for change mode, and then do A plus R all together, everyone, all, plus R for read, and then cat.jpg. Enter. Nothing seems to happen, which usually means a good thing. So ls-l again. Now let's look at cat.jpg, and these permissions seem to have changed. As an aside, if you make a mistake and you, for instance, just made your essay publicly accessible by accident, you can do the opposite, chmod A minus R, though frankly it shouldn't be in the public directory anyway, if that's the concern. So now let's go back to my browser and reload, and I'm going to click the little Ghostbuster symbol to clear that part of the screen so we can see new requests. And indeed, here is Grumpy Cat from before. But more importantly, technically, there is the number 200, which means we got it OK. All right, so that's all fine and good, but we're not making the best of websites, nor are we going to try too hard to make the fanciest of websites today. But let's at least do something super familiar before rattling off a few other tags. So suppose I don't just want a cat here. Suppose I actually want this cat to link to something. I might, for instance, do something like this. A for anchor, href for hyperreference, equals, and let's just do something like www.google.com, close quote, close bracket, and now search for cats, close anchor tag. So this has only one sort of fundamentally new detail. The tag, of course, is different. It's the name A for anchor, href for hyperreference. But more importantly, there's this syntactical feature here. This is what we'll start calling not a tag, but an attribute. And an attribute is something that modifies the behavior of a tag. And this attribute, href, means modify the behavior of this anchor so that when it's clicked, it goes to this URL here. And of course, that URL is Google. Meanwhile, what is this text here going to be? Well, that's going to be what the human actually sees as the underlined link. As simple as that. So let's try this. Let me save it. Still in hello.html, but in the versions online, you'll see the actual file names we pre-prepared. Let me go ahead and reload. And now it's a very underwhelming page still, but if I hover over there, and it's a little small, but you can see in the bottom left-hand corner of your screen, it's indeed going to google.com. And if I click that, it'll whisk me away to the actual Google. But notice here an opportunity for exploitation, just as an aside, and we'll come back to other issues of security before long. Because there's this dichotomy between where you go and what you say, you could do something like this, http://www.google.com. OK, and now if I reload after saving that page, looks like I'm going to go to Google. But there's no reason I have to go to Google, right? I could actually go to something like badguy.com, reload the page over here, and notice, still looks like Google. And only if I'm sharp enough to hover over here do I see it's even going to go to a different location. So if you've ever gotten an email, especially one from PayPal, or seemingly from PayPal, asking you to log into your account, this is why you should never, ever click links in emails. Frankly, any links in emails. If you know you have actual money in PayPal or Bank of America or Fidelity or any website, manually type it in. Because look how easy it is to trick someone into presenting what looks like a link, but it actually could go absolutely anywhere. And there's far greater threats than this. In fact, this is a bit of a tangent now, but one of the best ones I ever saw, which has since been closed, is someone led people to, so this might say, click here to log into your account, a bank account. And this was Bank of the West. So someone bought this. And it's a little easier to see it in a monospaced font zoomed in on a 30-foot projector. But when it's small font in an email that you're receiving, this looks like bankofthewest.com, not bankofthevest.com, which someone had paid $10 to buy. And then this led them to the equivalent of some bad website. And you'll see, too, actually, we can do this. If I go to the actual website, bankofthewest.com, again, recall from last time that if this is their web page and you're curious as to how it works, you can certainly go to Chrome's developer tools, and you can see all of the HTML nicely formatted there. But more to the point, you can, let's close this, you can go to View, Developer, View Source. Why don't I just copy all of that and then I can go into my little gedit window here and make my own web page, save this in hello.html, and probably this is going to break because it's not this easy usually. But now if I reload my own page on my own CS50 appliance and hit reload, OK, some stuff broke, but I'm pretty close to having my own banking website, right? All of this HTML, I didn't actually, and you know there's someone out there who would actually click these links too. So clearly some stuff broke, but that's going to lead us into a discussion unnecessarily right now as to like what CSS, cascading style sheets are, and how you actually download the other HTML files and JPEG files and GIF files that the website might be using. But all of that is accomplishable. But it really boils down to these very simple heuristics. So now let's just skim through a couple of other examples of HTML just to give you a sense of what else you can do. For instance, this is list.html. Suppose I wanted to make a web page with a list of houses in the quad. I might use the UL tag for unordered list, and then the list item child, and then iterate over, or list rather, the houses in question. And if I open this up, let's do this. Let's go not to hello.html, but to list.html. Damn it. How do I fix this? The same issue as before, right? So let me do chmod, whoops, chmod a plus r of list.html. And now if I go back to, if I go back to my browser and click reload, there it is. So if you've ever wanted to make a bulleted list, you can do that. If you want to be super fancy and make an ordered list, not an unordered list, change those to OL, reload the page, and now the browser will number it for you. What else can we do? Well, a couple of others. If you've got long paragraphs of text, for instance, some Latin text like this, and you want it in separate paragraphs, open P, close P for the paragraph tag, and do it again and again. And if I now open up this file, paragraphs.html, well, this is getting annoying. So now let's just go back to my prompt, chmod a plus r star.html. A nice little wild card, so to speak, should fix all of these problems for me. Let's reload. There's 3 paragraphs. And now let's go ahead and open up one other. How about table? Notice table looks a little more complex, but it's the same idea. Open tag, open tag, open tag, open, 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 close tag, open tag. And these happen to stand for table, whose border is apparently going to be of thickness 1, whatever that means. Table row, table data, which means a cell. And if I go back to my browser here and go to table.html, you can see something like this. Hideous, but we'll get to the point where we can actually make things prettier than that. So let me stipulate for now, there's bunches of more tags. And HTML is wonderful to pick up because, frankly, all you need to do is look at existing web pages with which you're familiar, and you're like, oh, that's how they did this aesthetically. Or you can look up any online resource as to how HTML works, and you'll see that there's a whole vocabulary of other tags. But with this simple mental model alone, that almost any tag you open has to be closed, it really does suffice to teach oneself HTML after understanding these basic ideas of tags and attributes and the well-formedness that we've talked about, closing anything that we might open so that we don't confuse a browser. So let's now take this to a more interesting level by going to the actual, and let's go to my Mac here, to google.com. And now notice, let's do this. I'm going to go to settings, search settings. I want to turn off this annoying instant results thing where it immediately starts responding to your typing. Let's do this older school so we actually see what's going on. So I'm going to save my Google settings here. And now notice I'm going to search for something like cats, and it's still doing autocomplete here, but based on things people have typed in the past. But notice what's going to happen. In the URL at the moment is this, just google.com, and technically it's slash. Google's just saving a character, not showing us that. They are showing us HTTPS just to be super reassuring that we're at a secure or encrypted page. So let me go ahead and search for cats. Now this got really overwhelming quickly. Look at the length of this URL. But it turns out that most of this stuff in the URL is actually pretty useless. I'm going to start deleting things I don't understand. I see cats. I understand cats. I don't know why cats are there again. I really don't know what this nonsense is. So I'm just going to keep highlighting and deleting stuff that I don't understand, distilling the URL into just this. Now let me hit enter again. Looks like Google still works. So for some reason, they're adding a lot of stuff to their URLs by default, but it's not strictly required. So what is nice about this? Well, let me go ahead and open up Chrome's inspector. There's a little keyboard, mouse shortcut for it. Go to the network tab. And now let me reload this page once more. And I'm holding Shift. As an aside, browsers tend to cache or save information just for efficiency's sake. But usually holding Shift and reloading will force everything to start over from the beginning. And that's what I want to do here. And notice all of these rows that just appeared. It turns out that in any given web page, there might be just one file involved, hello.html, or there might be 52, as in this case. When I visit google.com, apparently my browser kicks off 52 separate HTTP requests. Why is that? Well, look at what's inside of this web page up top. There's not only text, but there's actual images of cats over to the right. There's a colorful logo up here at left. There's all of these icons for like a microphone and so forth. There's a lot of pieces, building blocks, scratch pieces, if you will, to this web page. And what the browser is doing upon getting the very first file, which is this row here, it is essentially iterating over the HTML, top to bottom, left to right, looking for things like image tags or other tags that are mentioning other files. And when it sees them, goes and fetches them via HTTP, via the whole envelope metaphor, and then displays them in the appropriate location in the web page. But notice here, if I focus on the first row, search cats, notice that, indeed, it's using HTTP 1.1. And unfortunately, Google Chrome right now, in version 39, is kind of dumbing things down and not showing us the actual headers. But what was indeed sent is a request for not slash, but slash search, $Q equals cats. Now, why is that important? Well, I'm going to infer from this that if Google supports queries of this form, why don't I implement my own search engine for CS50, but just the front end, just the graphical user interface, and then we'll outsource the back end, the actual search results to Google. So how can I do this? Well, let me go into gedit over here, and let me go ahead and open up, let's say, a new file, and I'm going to save this temporarily as search0.html, and then eventually we'll fast forward to the one I pre-prepared, and I'm going to quickly whip up doctype HTML, open bracket HTML, close bracket HTML. Then I'm going to do head, close head, open title, CS50 search instead of Google search. Down here, I'm going to have the body. Down here, close body. And now I need CS50 search. And actually, let's build this incrementally. I'm going to go ahead and close this and actually put it in my public directory. So give me just one moment. Search0.html. I'm going to temporarily call it search.html. I'm going to chmod it a+r search.html. And now I'm going to open it. All right, so that was fast, but the goal simply was to get us to the point of having this text file called search.html. So not much to look at yet. Indeed, if I go to my browser and go to search.html, that's all it is. But you know what? I can be a little fancier. I read in a book that there's a heading tag called h1, and I'm going to go ahead and use that. Open h1 and close h1, reload the page, and now it's bigger and bolder. Not all that interesting, but at least it's structurally more interesting. But now let me introduce another tag. Turns out there's a form tag, and let me close that tag. And it turns out there's an input tag that has an attribute called type, which is the data type of the field, if you will. And this is going to be of type text. And its value is going to be CS50 search, close tag. And there's going to be no notion of opening and closing with separate tags. Let me go back over here and see what's going on. Reload. Getting interesting. It looks like it's a text field. And actually, I didn't want to put a value there yet. Let me go back here and actually get rid of this value to keep it simple. Instead of a value, what I wanted to give this thing was a name. And I don't know what it is, so I'll come back to that. But below that, I want to do input, type equals submit, and this value will be CS50 search. And we'll see why I move the value to this. When I reload, I seem to now have the beginnings of my own search engine. Super hideous, though frankly it's not a far throw from what Google's default page looks like. If I go here now, I can type in cats and hopefully click search. But I'm not quite done yet, because I haven't implemented, obviously, a database. I haven't crawled the web for search results, so I need to outsource that to Google. So how do I do this? Well, first of all, I need to add an action attribute to my form tag. That is http://www.google.com/search. And I know that only from having inferred by looking closely at their URLs. And now take a guess. What should this text field probably be called? Based on where we came from before. question mark Q. And we don't actually need the question mark, it turns out, but Q is indeed it. Q for query, probably, by default, just because that's what Larry and Sergey came up with years ago. So now let me reload this page. It doesn't look all that different, but now watch what happens. If I type in cats and click CS50 search and let go, notice I get whisked away to actual Google. Now, Google's being a little annoying in that they're appending an additional parameter, if you will, to the URL. That's all happening automatically on Google's side. The important part is that I seem to have generated this request here. And indeed, that's what happens. When you have HTML that looks like this, this is sort of web developers' notation for saying, go ahead and create a form that when it's submitted, it's going to go to this URL. And when the URL has provided values for things like Q, don't go just to this URL. Actually go to question mark, and then Q equals cats. Append the parameter, the HTTP parameter, like that. And just to be super precise, what's being inferred here, but I'll be more explicit, is that the method I want to use is get instead of something like post, which we'll eventually see. So in short, simply by understanding HTML and using some fairly simple tags, we can now begin to create our own front-end user interface with a search engine behind it. But this, of course, is pretty hideous. So let me actually open up a slightly better version. This is the one I prepared in advance that has some comments, but you'll see that I pretty much recreated it. So this is already available online. And I did happen to preemptively go to HTTPS just to keep it simple. And now let's open up a next iteration of this. This is version 1 instead of 0. What jumps out at you is slightly different in this example. Yeah, there's this text-aligned center. This is a little weird up here, but this is indeed new. And maybe guess what's going to happen. If I go to my browser now and visit search-1.html, it's almost the same thing, but it's a step closer to being a little more pretty. Still ugly, but prettier in that at least everything's now centered. So it turns out that what I'm using is another language altogether called CSS, Cascading Style Sheets. And CSS, frankly, is kind of, in my personal opinion, an atrociously designed language. It's very annoying to remember all of the various details, but it is what stylizes the entire World Wide Web today. I offended someone. All right, so let's go back here and see how we're actually using this. And it turns out, at least, it's actually a pretty simple language. It's just key-value pairs, properties and values, properties and values. Indeed, here is one such property and value. Simply by using the style attribute on my body tag and giving it a value of a word, colon, and another word, or a property and a value, I can affect the aesthetics of the web page. Not necessarily the structure yet, but the aesthetics of it. And just by Googling around, I realized that CSS, Cascading Style Sheet, supports a property called text-align, whose value can be left, right, or center, for instance. So now when I reload this page, what I did get was a centered page, but still pretty ugly. Let's go ahead and open up version 2 of search. And now notice I've done a little more. Notice that up here, inside of the head tag, there can be more than title. In fact, there's a style tag, and this is where it just gets a little messy, seeing CSS sometimes. Notice that I seem to have something that structurally looks very different, but here is the name of the tag I want to stylize. Here are our old friends curly braces and close curly brace, and then here is that property and its value. If I load this file, search2.html, the end result is identical, but it's a step toward better design. By factoring out this CSS, I've not commingled it with my HTML. And indeed, as we'll see, I could reuse these properties and values. If I wanted to make bunches of parts of my web page centered, I don't have to type style equals text-align center all over the place. I can put it in one place, perhaps, like up at the top. But even this isn't the best design. In fact, one of the things you'll learn as you spend more and more time with web programming is that the more you can modularize things and factor things out, like .h files let us factor stuff out, like helpers.c let us factor things out a few p-sets ago, similarly might we want to achieve this. So notice in version 3 of search.html, I've cleaned up the head of the page and just put in this, a link tag, which contrary to the name does not give you a hyperlink. It links to another file by way of an href, whose value in this case is search3.css. So I realize we're going quickly, but all I'm doing is kind of moving things around. Let me open search3.css. There it is. Nothing really to it. I just copied and pasted it into a new file, much like we factored stuff out into other files before. And the result, completely underwhelming. It's going to be exactly the same. But we're moving toward... No, it's not. Oh, I know why. So seems to be a bug, and it is in some sense, but let me open up my network tab. Let me reload the page. Why is the CSS not being applied? Well, the CSS file similarly has to be world readable, so to speak. And it too is currently forbidden, so let me do a chmod a+r of star.css, where .css is just the file extension for CSS files. Now let me go back to my browser and reload. OK, a little better. Now let me do one last thing. In search for.html, I have a version that I just thought was way cooler, albeit way more complicated. Let's look at the result first. Close this to give us more room. Change this to search for. Enter. And now a bunch of things are broken. I'm going to go back into my directory here. And now I'm just going to do a chmod of a+r on a file, because I know it exists, called logo.gif, which is an image. And now reload. And wow. So now I'm pretty close, frankly, to like the 1999 version of Google, and frankly, the 2014 version of Google. Right? So it's now going to their website, ultimately, if I search for cats. And indeed, it is. But what did I do differently in this version 4? So we won't dwell too much on it here. You'll see this in problem set 7 eventually. But notice I did a few things. I introduced a div tag, which is division, similar in spirit to a paragraph tag, but a division is just like, here's a rectangular invisible region of the screen. Let's give it a unique identifier of footer, just so that we can talk about it in our HTML elsewhere. Here's another div of the page, whose ID is going to be content. It's the content of the page, and up here is the header of the page. In other words, I've essentially, in HTML, mentally viewing this web page as 3 components: a header up here with this invisible rectangle, the content in the middle, and then the footer down below, even though we don't see those things, because I want to, in my head of the page here, or in a .css file, I can use this syntax. Header is not a tag, it's an ID, so it turns out that by doing #header, I can now apply one or more properties to the header. I can do the same for content, the same for content here. So for instance, in the footer, notice all of these properties I'm adding. And I know they exist just by reading up on the documentation for CSS. Font size is going to be smaller, so some relative font size. The weight is going to be bold. Margin and how many pixels around it is 20 pixels, and it's going to be centered. But right now, the page looks like this. If I'm not pleased with my copy right there, I could do something like color red, and then I can save this, reload, and now I've stylized the footer. So this is just hinting at the power of what you can do in a web page to change things around. And even cooler than this, if you want to poke around with actual websites, you can't permanently change them. But if I open up Chrome's inspector again, and I go not to the left-hand side here, which shows Facebook's HTML, but shows on the right-hand side all of its CSS, you can even change things on the fly. So let me go ahead and do this. Let me go ahead and control-click on this random word here, sign, and click Inspect Element. Chrome very conveniently jumps to the H1 tag that Facebook is using. And notice here, Facebook has kind of lazily hard-coded font size as a property here. So the cool thing, though, is that if I actually go in here and say, oh, Facebook, I don't like that, 64 pixels, we can now change Facebook. Of course, we're only changing it for me personally at the moment, but this is just another tool in our toolkit that's going to allow us to tweak and figure out and also diagnose issues in our own web pages. And we could similarly go over here, which is the same thing. If you really want to get fancy, I mean, now you can really mutate the page and do crazy things. So why is this all useful? Well, ultimately, we're going to want to be able to create web pages that are driven by our own backends, not by just Google and outsourcing the backend there. We actually want the value, for instance, of our search engine's action attribute to go not to someone else, but to something like search.php, where search.php is on our own server, not on someone else's. And so to get there, we actually need to introduce a new language. So we've already looked at one new language here, or two really, HTML and CSS, but they really are just structural and aesthetic languages. They're not programming languages per se, and that's about as much formal time as we'll spend on them, because we'll begin now to transition to PHP. So PHP is an actual programming language. It's a scripting language in the sense that it's meant to be lighter weight than something like C. And it's an interpreted language, which means it's not compiled. So in a nutshell, what did it mean when we used a language like C and we had to compile it? What does it mean to compile C source code? Say again? Perfect. It turns it into binary. It turns it into zeros and ones from actual English-like source code. And then we can actually run those zeros and ones by passing them through the CPU, by double-clicking an icon or running a command. PHP and Python and Ruby and Perl and JavaScript and bunches of other languages are interpreted languages, which is to say you do not compile them. Rather, you feed them as input to a program called an interpreter, and that interpreter, which someone else wrote, reads your source code top to bottom, left to right, and just interprets those lines and does what you say. So if you encounter a line that says print, it doesn't necessarily convert print to the corresponding zeros and ones. It just has this interpreter, like a big if condition, that says if programmer's instruction is print, then do the following. So it interprets it just by kind of reasoning through what you're telling it to do. And PHP is one of these languages, and PHP years ago was designed precisely for web programming. And it was initially a very sloppy, messy language. And indeed, there's a huge amount of bad PHP code out there. But the language itself has matured over the years, so much so that now it's actually a wonderful next step pedagogically from C, because it's so darn familiar to everything you've just seen in the past few weeks. The one initial difference we'll see is there's no main function anymore. When you start writing code, it's just going to get executed no matter what, as we'll see in a moment. Meanwhile, here's what a variable looks like in PHP. It's a little different, but only barely. In PHP, there's not strong typing. There's weak typing, which just means there are data types like strings and numbers and other things, but you don't bother specifying what they are anymore. PHP figures it out for you. The $ is just a decision that the PHP people made years ago, such that any variable in PHP just starts with a $. It's actually kind of useful in that it jumps out at you a little more. But after that, this is a condition in PHP. What's different versus C? Trick question. Nothing, which is actually really nice. Boolean expressions in PHP, the same. Boolean expressions with ands versus ors. Switches, loops, loops, loops. OK, this one is different. So it turns out there's a couple of other features in PHP. One of them is actually this, which is wonderfully convenient. If $numbers is an array that you've declared previously in a program, you have this fancy for each construct that instead of doing all of that annoying I equals 0, I is less than this, I plus plus, for each numbers as number, where each of those $ values is just a variable, and the latter you can think of as I. I could call it anything you want. I called it number. This is going to iterate over the array called numbers, and on each iteration, it's going to automatically update for you the $number variable so that you constantly have access to the variable you want without having to do any square bracket notation or indexing into an array. Beyond that, we even have things like arrays, which look almost the same, except it's very common, as we'll see, both in PHP and JavaScript, to pre-initialize an array using square brackets. C uses curly braces, so it's slightly different, even though we didn't really use that trick much. But even more powerfully, PHP has associative arrays, which is a fancy way of saying hash tables. In fact, if you want to declare a hash table in PHP, unlike in C, how many lines of code did it take to actually implement a hash table in C? Or how many lines of code is it taking to implement a hash table in C? So it's probably a lot, right? It's a few dozen, maybe 100 or 2. It's non-trivial, or it's about to be, as you'll soon see, non-trivial to implement a hash table and also a trie. But in PHP, and frankly, I probably shouldn't tell you this till Monday, in PHP, if you want a table, done. That's a hash table. So with one line of code, and a lot of languages do this. Have fun with pset5. So a lot of languages do this. They give you these abstractions that other people, other programmers have created for you so that you can stand on their shoulders and start using ideas that are super compelling, like hash tables and trees and tries, but you don't necessarily have to implement those things yourself. And so ultimately, what we're going to use PHP for is potentially writing programs at the so-called command line. We could recreate every program we've written this semester thus far, except maybe Breakout, which uses SPL, which is specific to C at the moment. But every other problem set, certainly Mario and Caesar and Visionaire and Crack and onward, we could re-implement in PHP, and probably a little more easily. But what we're ultimately going to use PHP for is web programming. And we're going to introduce next week a mental model, a paradigm called MVC, Model View Controller, which if you've done programming before in Python or Ruby or elsewhere, you might know of this scheme with Rails and Django and the like. But if you're new to this too, you'll see that this is actually a very natural extension of the factorization and the sort of design of code that we've been doing in C. We're going to now apply some of those lessons to PHP so that ultimately we are implementing our own websites. And if you're sort of mesmerized or amazed that we're going to do all of this so quickly, realize that almost every semester, nearly 90% of students in CS50, including those who have never programmed before, end up making final projects that are based on web programming. And so you will see that the returns are high in the weeks to come. So we will see you then on Monday.
And now, Deep Thoughts by Davin Farnham. Hash table.